Hello everyone, my name is Prakriti P. I'm a second year computer science engineering student studying in Sri Venkateshwara College of Engineering, and today I'm here to give a presentation on central limit theorem in the subject mathematics for CSE stream. To begin with, I'll be covering the topics which is the central limit theorem, what are its key components, how it is useful, its formula, statement, properties and assumption. So, what is central limit theorem? Central limit theorem can be defined, or it can be stated that it is a distribution of sample means which approximates a normal distribution as the size gets larger, regardless of its population distribution. A sample size is which is equal to or greater than 30 are often also considered as sufficient for central limit theorem to be held. So, what are the key components of the central limit theorem? Here are few key components for the central limit theorem. The first one is sampling is successive. Sampling is successive. This means that there are some sample units which are also common with the other sample units, and these can be selected on the previous occasions. So, this is known as sampling is successive. Sampling is random. All the samples must be selected accordingly, so that randomly, so that they can have the same statistical possibility of being selected. This is known as the sampling is random, which is the second component of the central limit theorem. And the third component is that sample should be independent. There are sections, or there are selections or results from one sample which should not have the bearing on the future of the other samples or the sample results. So the samples must always be independent, so that there is no selection or results from one sample which will affect the future of another sample results. So that's known as this. That's the meaning of samples should be independent. And the fourth component, which is the samples should be limited. Here it means that it is often cited that the sample should be not more than 10% of the population, and if the sampling is done without replacement, then the larger the population size, wherein then the user of the larger sample size. So the sample should be limited. So this is one of the component of the central limit theorem. And the last component is that the sample size is increasing. The central limit theorem is relevant to more samples which are selected, so the sample size is increasing. So why is central limit theorem so useful? So central limit theorem is mainly useful because it helps us for analyzing a large data sets, because it allows us to assume that the sampling distribution of the mean will be normally distributed in most of the cases. And this also allows us to have an easier statistical analysis and interference. And I can give you an example is that when an investor uses a central limit theorem to aggregate the individual security performance data, and also generate the distribution of the sample means, which represents the larger population distribution for the security returns over a period of time. This can be an example of the sample central limit theorem, where it can be useful. And now we'll look at the formula of the central limit theorem. There is no particular, it does not have its own formula, or it does not have a particular formula, but it relies on the sample mean and the standard deviation. As a sample means are gathered from the population, and standard deviation is also used to distribute the data across the probability distribution curve. And the central limit theorem for a sample is z is equals to x bar minus mu the whole divided by sigma the whole root of square root of n. This is, as you can see in the slide, this is the central limit theorem formula for the sample mean. Now we can come to the statement of the central limit theorem. So here is the statement of the central limit theorem, which states that whenever a random sample of a size n is taken from any distribution with the mean and variance, then the sample mean will be approximately a normal distribution with mean and variance, or the larger the value of the sample size, the better is the approximation of the normal. So this is what the central limit theorem states. So what are the properties of the central limit theorem? Here are a few properties of central limit theorem which is given here, which is sampling form. For sampling is a form of distribution that with mean and standard deviation. So this is the first property of the central limit theorem. And the second property is that it is the n is greater. If the n is greater than 30, then the rule is thumb. The sampling distribution of the sample mean will be approximately a normal distribution with the mean, and a standard deviation is equal to sigma the whole divided by root n. And if the sample distribution is normal, then the sampling distribution of the sample mean will be exactly a normal distribution for any sample size. So what are the assumptions of the central limit theorem? Some of the assumption of the central limit theorem is that the sample should be drawn randomly from the following conditions of randomness, whereas the samples drawn should be also independent to each other, and they should not influence each other. This is one of the assumption of the central limit theorem. And then it is also assumed that the sampling is done without replacement, and the sample size shouldn't exceed, because the sample size shouldn't exceed 10% of the total population, and the sample size